Hello people, welcome back. This one mark question is from GATE 2007 exam. Read it. They are saying what is the maximum size of data that application layer can pass to TCP layer below. Now application layer gives data to the lower layers. That means TCP layer. TCP layer or the transport layer takes that data and makes segments. Okay. So this is one segment. Whatever is the maximum limit that can be placed in the biggest segment is called 1 MSS. Now, application layer is not aware of all of this process and application layer does not care what is the size of 1 MSS. Application layer will give any amount of data to TCP layer or the transport layer. For example, if you want to send some very big file, say you are uploading a video on YouTube that is 10 hours long. Okay, it can be of 10 GBs. Application layer will directly give that 10 GB file to the transport layer. Now it is the duty of transport layer to break that file or chop that file into smaller parts such that one part is able to fit into this segment easily. Okay, so answer to this question will be the maximum size of data that application layer can pass to TCP layer below is any size. Okay. Application layer does not care about all of these numbers and all of these limitations at various layers. Application layer will directly ask TCP layer to send a file of arbitrary size on the network. Okay. It is the duty of transport layer to chop the file into appropriate sizes. Okay. Now have a look at option B, C and D. All of these options are very cleverly formed to confuse you. Okay. If you don't know about this fact, you might get confused. For example, this option C is 2 raised to the power 16 bytes. This is almost equal to the maximum size of a IP datagram. What is the maximum size of IP datagram possible? It is 2 raised to the power 16 minus 1 bytes. Okay. So this option is just to confuse you. See, in a IP header, there is a field called total length. Total length is of 16 bits. With 16 bits, this is the biggest number that can be represented. That means total length can represent 2 raised to the power 16 minus 1. Okay, this is the biggest number. That means total length can be these many bytes. Okay. So this option might confuse you. And this is one step ahead. Okay, see. If this number, this is 65536. But the total length is 65536 minus 1. So you'll get 65535. This is the total length of a IP packet. Inside this IP packet, in the data part of this packet, you will be having a TCP segment. Okay. And maximum data that can be contained in this TCP segment is this much. That means 65535 minus 20 for the IP header and TCP header. Okay. So maximum data will be 2 power 16 minus 1 minus 40 bytes. This is if we assume that the header is of minimum size, 20 bytes each. Okay. So minus the size of TCP header, they are just trying to confuse you. Option D says 1500 bytes. 1500 bytes is the MTU at data link layer when we are using the standard Ethernet. Okay. If you are using standard Ethernet, the frame size will be 1518 bytes. You remove header and the trailer, you will get 1500 bytes. So maximum transmittable unit is 1500 bytes. That means the IP packet has to be maximum of this length if there is such a limitation on the data link layer, because eventually IP packet has to be placed inside a frame. This much big IP packet cannot be placed inside a standard Ethernet frame. Okay. Similarly, you can see 1500 minus 20 will be the MSS. That means maximum segment size that can be placed in the transport layer packet or a TCP segment. Okay. But application layer does not care about all of these facts. Application layer will just give data to transport layer. Now it is the duty of transport layer to find out that what is the bottleneck size. Is data link layer creating a bottleneck or is the network layer creating a bottleneck? For example, if data link layer says I can accommodate up to 1 lakh bytes, then this is the smaller number. Okay, then segments will be formed according to the limitation of network layer. But if data link layer says I can have only a maximum of 20,000 bytes in one frame, then at this layer the limitation is 25,000 bytes. Here the limitation is 65,000 bytes, almost 65,000. Okay, that means this one is the bottleneck. In that case, transport layer will create segments according to data link layer limitation. Okay, so option D is also there to confuse you. Anyways, this one is not even correct. First thing is it is not correct because application layer does not care about how much data can be placed in a transport layer segment. Second thing is, even if we take that into account, still in that case, the maximum data that can be placed in a transport layer packet will be 1500 minus 40. Okay, we have to consider these two headers also. That is 40 bytes, 20 plus 20 in case if the header size is minimum. Okay, that means 20 bytes here and 20 bytes here. Okay, so suppose there is option D which says 1500 minus 40, these many bytes. This one will also not be the answer because already I have repeated it 3 to 4 times that application layer does not know about all of these facts. Okay, but this one could be placed in the options to confuse you even more. You might think that if 1500 is the limit here, then the limit here will be 1500 minus 40. But application layer does not know about this limit. It is duty of this transport layer to create packets such that the data fits here exactly, keeping this limit or this limit into mind. Okay, so thank you very much for watching this video. I hope you have understood this concept. Have a good day.